Okay, inclined plane. You should have a picture of inclined plane on your mind. When you say something is inclined, it's just like, then you put something here. That's just it. Then you want to push this up. Remember, it's going up. Then there will be another force that pulls it down. Then sometimes you have gravitational force on it. And again, you have the weights, or you have the weight of this. All of these forces added together will actually is what we'll be considering. Okay, this is just a rough sketch. So let's take an example where we have a box weighing 500 kilograms. It's placed on a plane, and this plane is inclined at an angle alpha. Now we say ignore the frictional force. Then we want to compute one, the minimum force required to stop the box from sliding. We want to find the force exerted by the box against the inclined plane surface. We'll take this one after the other. The first thing we want to find is the minimum force required to stop the box from sliding down. Remember, there's a force required to push this box down, and there's another force required to push it up. So both forces are acting on this box, and the box also has its own weight. How do we resolve and find the minimum force that we need such that the box will not go down? So that's what we want to look at. I've said that, note, the angle formed by FA. Can you see this diagram properly? Oh, okay. Someone is already solving the question. That's nice. But for the sake of others, let me explain. If you look at this box, right, there's a force that pulls it down. That's what I've called FD. There's a weight of this box, 500. There is another force, FA, which will be equal. I mean, no, it's not equal. There's another force, FA. What did I represent FA as? I think it's there. A box is placed on a plane at this angle. Ignore the frictional. Okay, find the force FA exerted by the box. That's FA. I don't want to represent it as something else. FA. That's FA. The force exerted by the box against the inclined plane surface. I call that the gravitational force, but don't worry, let's not confuse ourselves. Let's just leave it as the force exerted by the box against the inclined plane. So if you look at it, that's the force exerted by the box, FA, this one, against the plane. FD is the force to pull it down. W is the weight of the box. And this box is actually at angle 90. One angle 11.2 rather. Okay. And when you look at it, this is the same as this angle. This angle is the same as this angle. And that's what I've said. That note that the angle theta formed by the force exerted by the box on the plane. FA, let's just stick to one nomenclature. FA is the force, that's what I've highlighted here. I don't want you guys to be confused. I want us to have the same representation. FA is the force exerted by the box against the inclined plane surface, okay? Yes, it can be the normal force. Just, I don't want to use terms that will confuse others. Let's just leave it as the force exerted by the box against the inclined plane surface. All right. Okay. So that is FA. And you see FA, I'm saying note that angle theta formed by FA, by this force, and the weight of the box is equal to the angle of inclination. This is the angle of inclination, okay? Alpha, which is 11.2 degrees. And so we represent this angle as 11.2 degree, because it's equal to alpha. So by the time we draw out the triangle completely, that's what I've drawn out as figure B. You would see the picture very well here. Look at FD. If I represent it as a vector, this is FD, this is FA, and this is the weight of the box. Okay? So tell me, what direction would FD be pointing at? In figure B, will it point to the back or to the front? Can someone tell me what direction? I want to draw the arrow, the angle, the arrow. Should it point to the left or to the right? Okay, it should point to the, yes, you're correct. So it points this way. Okay, and FA, what direction? Should it point downward or upward? The arrow for FA, this is FA. Should it point downwards or upwards? Yes. And then W will point where? In which direction? Downwards or upwards? Yes. Okay, so it shows we're following. Thank you. That's how the arrows will point. Now, we want to find the force required, the minimum force actually, to stop the box from sliding down. Okay, and how do we find that? We have our angle theta, which is alpha, which is, we know it is 11.2. We know W is 500, right? 500. You can leave it in Newton. This is just an example. Okay, I'm not specifically pointing to the units here. I want you to understand resultants and how we apply Pythagoras theorem, angles, compute angles, and all of that. Okay. So we have W to be 500. Then we have, do we have FA? So we're looking for the force required to stop. We're looking for FD, right? So what trigonometric ratio are we using? Thank you. We're using the sine ratio. So it will be W sine, let me write it here. W sine alpha or theta, yeah. Sine alpha. This is what we have done. And W is 500, alpha is 11.2. So we have got this to be the minimum weight, force required to avoid this box from sliding down. Then the second question, let's go back, says find the force FA exerted by the box against the inclined plane surface. So now we have found this angle, this side to be 97.1. Then what is this side? Just back to your question, Adil, the forces, if one of the side is given in Newton and the other one is given in kilogram, then you need to convert to keep the same units. And that means you need to convert from kg to Newton. Do you get it now? That's another key thing you must know when you're doing computation. And let's say you're given a side in the standard unit, maybe in Newton, and you are given another one in kilogram, then you need to make a conversion to keep it constant, to keep the standard unit constant. All right. So I just needed to say that. Okay, so we're looking for FA. This is FA. We know theta. So we're going to use what? Trigonometry ratio. What trig ratio are we using here? Can someone tell me? This is where what we're looking for, X, FA. I'm waiting. Okay. Is it possible? This is another question. Is it possible that we use Pythagoras theorem to find FA in this case? And okay, can every one of you use Pythagoras theorem and tell me what your answer is? Use Pythagoras theorem and tell me what your answer is. Okay. So you see, you can either use Pythagoras theorem or you use the trig ratio. And why can we use why do we say we can use Pythagoras theorem? It's because we are having a right angle triangle. If this is not a right angle triangle, then we will not be able to use Pythagoras theorem. All right. Just moving on now. This is about the last part of the first part of our lecture. We're considering reduction formula. Reduction formula is actually used to reduce a huge angle. Take, for instance, you have been given an angle 900 degrees. Okay? Remember, we only have 4 quadrants, and we want the angle to fall into one quadrant. And so we need to reduce that angle from 900. I'm just using 900 as an example. From that huge degrees, which is 900, we must reduce it to one of the 4 quadrants. Okay? And that is why we do reduction. And that is why we actually have reduction formula. Reduction formula is given in two terms. We have reduction along the x-axis and reduction along y-axis. Reduction along x-axis, I want you to just sketch it on your paper. Just draw the four quadrants. And on your x-axis, your x-axis is the horizontal line, right? And your y-axis is the vertical line. On your x-axis, you have to the left is 180 degrees and to the right is 360 degrees. Let me just see if I can sketch that here. What I'm saying is, assuming this is mine. Let's assume this, okay? Sorry about the not straight thing. This is my x, and this is my y-axis, right? Now, if you look at this, this is 180 degrees, and this is 360 degrees, right? Sorry, this 360, this is 90, and this is what? 270. Okay, so this is what I'm saying. So we can either reduce along the x-axis between 180 and 360, or we reduce along the y-axis between 90 and 270 degrees. That's what it means by reduction along x-axis or along y-axis. All right, I hope that is clear. K is just a constant. It's a constant. It's a positive constant. Or no, it's a constant actually. Or it can be any integer. That's what I've written here. So you'll see that in example. Let's say you have I want to see 360 times 4. That will be 1,440. Let's say you are given the angle to be 1,440. You want to reduce it along x-axis now. It's just going to be 360 times 4. So your k, the integer there will be 4. And your theta will be just maybe 0 degrees. Here, this is what I'm saying. You get it? Okay. So these are the formulas for reducing. You want to reduce along the first quadrant, you use this form. It could be 360 degrees times k. This is k, 360 times 4, or 360 times 2, or 360 times 1, or whatever k the integer is. Then you add it to your theta. And then the final answer here, when you would say reduction, would be the value of we'll get to an example. We'll get to an example. I need to explain this because I saw a lot of people maybe did not understand how to reduce in the assignment. So I just need you to understand it with the quadrant. So you have theta plus 360 degrees times k. I'm taking this first quadrant now. You want to reduce along x-axis. So in this case now, whatever the value, you say whatever the value of this theta is what you pick out, and then you make it the final sign. Your final answer will be sine of that theta, of this theta. We'll get to an example, you see what I mean. If you're considering cosine, let me go to this third quadrant. Let's say for cosine, you have 180k plus theta. Whatever the value of theta is here is what you put as your final cos theta, but you still need to add the sine. So theta in this case is not positive, it's minus. So you must include the sign. So when you're doing reduction, you consider the sign and the reduced angle. So those are the two things you must be writing as your final answer. It must be the sign. In this case, cos is negative. You must have a negative cos, and then the reduced angle, which is theta. That is along x-axis. We'll get to an example. You see what I mean. The same thing along the y-axis. Along the y-axis, you would not be using 180 and 360 as your formula. You need to use 90 and 270, and that's what I drew initially, because you have y, this is y, okay? And this is 90, and this is 270. Please don't make a mistake of using x-axis when you're told to reduce along y-axis. And I've emphasized this enough so that everybody would know that there's a difference between reduce along x-axis and reduce along y-axis. Reduce along x-axis, you use either 180 or 360, depending on the quadrant at which it falls to. If you're told to reduce along y-axis, reduce using 90 or 270, depending on the quadrant at which it falls to. Is that clear? Before we go to the example, are we clear now? Okay, thank you. Now we'll see some examples. Here in this example, I said reduce each along x-axis. Reduce sec number 1, sec minus 27, minus 227 degrees along, please take notes, along x-axis. It's important, along x-axis. Okay? And then what do we do? Remember, does the function change for 90 and 270? What do you mean by the function? Are you talking about the trig function, cos, sine, cot? It does. When you look at this, that's why I said depending on the quadrant at which you have it. If you have, you see, sine 90 has changed, sine 90k minus theta is equal to cos theta. Yes, that okay. That's it. You can see it. Your example is just the first one on the second quadrant. Okay, Talenta, are we on the same page? Talenta, are we on the same page before I go on? Oh, so you want me to go back to this? You would see it when we get to the example. Black hole, yeah, I mentioned it initially at the start of today's lecture that I purposely gave that assignment so that you would be able to study the lecture notes, okay? And so that you will have a good understanding by the time we take the class. I would decide what to do with the assignment because I saw a number of students did not perform well. Okay, I'm aware of that. I know. So don't worry about it. I'll decide and let you know what to do after today's class, and that's why I'm taking my time actually to teach you in order to understand it. Okay. Okay. Don't worry. I know what to do about the grades. Don't just focus on today's lecture. Make sure you get all the concepts. Make sure you understand it. and then I'll give more information about the assignment. Okay. Yeah, I see a lot of students did, of course, because we've not studied, or we didn't go through this together. I know, I understand. So let's see the example, sec minus 227 degrees. In this case, you discover that minus 227 degrees. Please, let's not disrupt the class. Okay, let's not disrupt the class. Let's just focus on the lesson. At the end, I'll tell you what we do about the assignment. All right, that's the second assignment, not the first assignment. So reduce sec minus 227 degrees along x-axis. If you observe minus, okay, we'll go back to the table. Wait, minus 227 degree is actually less than 0 degree, okay? And that is the first thing you must always notice, consider when you're doing reduction. Is your degree less than 0 degree? If it's less than 0 degree, what should you do? You find the coterminal angle of that angle. And what is the coterminal angle of 227 or minus 227? It's actually 133. How do I get that? I think every one of you knows how to find the coterminal. Let's say we are reducing along x-axis. That's 360 minus. You may want to do this. That's just a short way to get around it. 360 minus 227 would be what? 133. Okay, so we have 133 degrees to be a coterminal angle of minus 227. Is that right? Do we all agree? I've shown you that. So what we now need to do is we'll now go back to our table. Okay, sec minus 227 is the same thing as sec, that's just what I've done, the coterminal minus 360, which is sec 133 degrees. So instead of using sec minus 227 degrees, I would rather want to use sec 133 degrees. Now I want to reduce sec 133 degrees along x-axis. So we're going back to the table. Okay. Let's now go back to our table along the x-axis. So which quadrant does 133 degree falls to? Yes, quadrant 2. So we have quadrant 2, and if we want to work in quadrant 2, this is what we'll be looking at, right? So we'll be having sec 180 degrees K minus 133 degrees, right? And what is K in this case? K is just 1. So we have sec 180 degrees minus 133 degrees. Remember that we have actually got the code, we are using the coterminal of minus 227 already. So we are going to be using 133 degrees as theta. So what our final answer will be is going to be minus sec 133 degrees, just using this table. Okay, let me go back to that now to see. So it's minus sec 180 minus 133. And it is 180 K, please write it down. 180k minus theta. That's what we are using from the table, sec. So what is our theta? What is our k rather? Our k is just 1 minus our theta is 133. Remember, we are using the coterminal angle. Then we have 180 minus 133 is what? It's 47. Or you may want to jump a step. I've just written all of this out for you to be clear. You may want to jump a step and then say, what is 133 degrees? And that's just what I've written. 133 degrees. Also, the coterminal of 133 is 180 minus 133. You see, what? So when does the k change from 1? You'll see where it changes from 1. So we have our final answer as this. There are 2 examples that I want to show you so that you will have a clear understanding. That is our final answer. And the final, okay, I expect a lot of questions. I'll take you back to this table. Let me start from Adam. You want to know when the k coefficient change from 1. We'll see an example and you see why we change it from 1. And that's basically when our degree is very huge. I've mentioned it. When the degree is very huge, we're going to change the k to fall within that degree. Then no. Okay, I'm taking the questions one after the other. I think I've answered you, Adam, but I'll show you an example of that. Talenta, why sec negative? This is the formula we are using. And when you look at this formula, what is sec in this quadrant? That's talenta. You see, sec is negative. And that is why sec is negative. Couldn't we make k equals 1 and make it sec 180k minus, what? Make k negative 1, 180k minus theta. So if you're making it this way, that shows that you have jumped a lot of things. And here, I can easily tell you what the answer is. The answer will be minus sec 47, which is right, okay? This is correct. What you have written here is correct, Milos and Luazi, which is correct because I'll just pick theta to be 47 and I'll go to the table and look at the sign of sec and see it's negative. I'll just write it to be minus sec 47, which is correct. It's the same answer, but sign is positive. No, we are looking at sec, not sign. Oh, okay. You're pointing out something. Sec is only positive in the 4th quadrant. Okay? Sec is positive in the 4th quadrant. That's just the reduction formula. All right? Remember, this is along the x-axis. This is along the x-axis. Okay? So it doesn't follow the same rule that we have with the quadrant rule when we are not doing reduction. Okay? This is just the reduction table along x-axis and along y-axis. They are 2 different things. Okay? What again? I'm just trying to go to the second example. Okay, is this the second example? Yeah. So is this? Yes, this is the second example. Look at the same way, minus 1,155 degrees. You can see 1,155, it's very huge, but I mean, it's very low, it's less than zero. So the first thing is to just get the coterminal of it. And how do you get the coterminal of it? You look at subtracting 285 from 360. But in that case, I'm just getting the coterminal. I'm showing you just an easy way to get the coterminal. You have 115. Let me just show you this straightforward. 115 is what? If you divide this into 360 places, 1155 will be 360, will fall under 360 times 4. I'm sure about that. Okay, so that would be like 360 times 4, right? Okay, it's yes, 1440. Yeah. So the coterminal of that will give you 285 degrees. Okay, please confirm that. I know we have done coterminals and I'm sure you know how to find coterminals. Please confirm that at your own time. I'm just looking at our time here. So the coterminal of this will be 285 degrees. Now, we are going to be using the coterminal, which is 285 degrees. Now we want to, which quadrant does it fall to? Let's go back to our table. Remember, we are doing along x-axis. Let's go back to our table, the x-axis. 285 degrees falls under which quadrant? Thank you. Fourth quadrant. So, and what are we trying to solve? Cosine, right? Sorry, tan. We are solving for tan. So it is tan. Let's look at it here. It will be this. This is what we'll be doing. I hope you can see what I'm highlighting. It's not allowing me to highlight. This is what we'll be looking at. So our final result will be negative tan theta. So the sign is important, which is negative. Okay, so we should be having negative tan theta. Now let's go back to the question. So it will be tan 285 degrees minus. Now I want to answer your question where 1 will be changed, where we will not be using 1. Okay, we can say tan 360 degree K minus theta. Okay, so that's because we are having negative, we can have it to be you're not going to be losing mark because of course I don't really expect you to show your workings for coterminal. That's something you should know. So it's 135. Did I say 135? No, 285 minus 360. What is K now? I want to ask from someone. Hold on, no one must tell me. I want to ask specifically from Selepe. Is it? No, from Adam. Adam, what will be K in this case? Oh, yes. Now you see K is no more 1, okay? And that's how you use, that's what you do. It's not necessarily your K will be 1, but when it doesn't fall within that range of 360 or 180 or 270, yes, exactly. Maybe that's the best way you understand it. Is the amount of 360 degrees, the amount of rotation, actually. Okay. So you have understood this. Now we have picked the angle is tan 285 degrees, okay, using the coterminal. And since this falls in the fourth quadrant, it is minus tan 360 minus 385, which is minus tan 75. Let's look at this, which just falls exactly in the third quadrant. In this case, that's example number 3. And that's where I'm going. In example number 3, you see that this actually falls directly in the third quadrant. That's 232 degrees. It's not less than 0, so we are not meant to look for the coterminal. You only get the coterminal when it is less than 0, okay? So now in this case, in example 3, it just fits in third quadrant. So basically what we'll do is go to the third quadrant in the table. We are looking at sine. We want to find sine 232 degrees, sine 232 degrees. Let's go to the third quadrant. All right. I'll take you back to the third quadrant. And we're looking at sine. This is what we'll be considering. So our final answer will actually be minus sine theta. Take note of the sign. And now we'll be dealing with 180K plus theta. All right. So let's go back to our question, sine. So we'll be dealing with 180K. Of course, 232 is not 2 rotations of 180 degrees. So that's why K is 1. It's just a single rotation. And then we have sine, it's in the third quadrant, sine 180 times 1, that's 1 rotation, plus, we're not using 360 because it falls in the third quadrant. I don't want you to get yourself confused. Basic thing is, what quadrant does it fall into? This 232 is in the third quadrant, right? Am I right? I mean, please take your time to think about this. Try to understand it. If you have sine 350, which quadrant would that fall to? If you have, I'm asking Talenta now. If you are to look for 350 degrees, yeah, so that's it. That's when you use 360. Don't get yourself confused. Take your time to understand. Your quadrant table, the initial one you have known, will help you to determine what quadrant your degrees falls into. Okay? Now, when you're sure which quadrant it falls into, you go to your quadrant table and just look. Yes, you can see the quadrant table. Let me take you back to the quadrant table. Let me take you to the quadrant. You can see the quadrant table shows you. The quadrant table shows you the formula to use. If that helps. The quadrant table shows you the formula to use in which quadrant. So if you have a degree or a value that falls in a specific years, is it because it's closer to 270? No, just okay. Just let's draw this. I'll draw. Let me do this. Let me do this. Okay. Let's do this. Yes, the reduction formula will be given. Let's do this. This is your first, second, third, fourth quadrant, right? This is your 90 degrees, your 180 degrees. Yes, I'll give the quadrant, I'll give a reduction formula table. Don't worry. This is your 270, and this is your 360. Okay, this is what you know, the quadrant table you know. Now, when 232 is what we are considering. Which quadrant? It's in this quadrant, right? And that's in the third quadrant. That's what I've been trying to say, right? Now, I'll stop sharing this. I'll share my file again. So this is all I'm trying to explain to you, that look, use your quadrant table to identify which quadrants this degree which you have been given falls to. And once you have identified the quadrant, you go to your quadrant, you go to your reduction formula table, and you use that to, you use the formula to then solve for that angle that is given. That's all you need to do. Okay. Yeah. Okay, so that's to answer your question, Wabiza. Then now we're sure this is in quadrant 3. This is in quadrant 3. We're sure of that. And we want to use the formula in the reduction table to solve. So what we are going to do is, to get our value, we're just going to use 180. That's 180 minus, actually, I've turned it the other way around, but this is what we have. Let's just follow the table as it is. So we are in the third quadrant and we are doing for sine. So it's this. Oh, please, can we just go on break and come back? Ah, I forgot it's past 11. Mm, 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 mm. No, sorry, I think I missed something.